The Wheel of Time is coming to Amazon Prime, and I could not be more excited to see this story on television for the first time ever. I started reading Wheel of Time in high school right after Book 8, The Path of Daggers, was published. I was always struck by the solid consistency across the story and across the world that Robert Jordan, the author, crafted, and I was delighted to see in his biography that he majored in physics. So this series is my exploration of how Robert Jordan's understanding of physics influenced his writing and shows up across this remarkable story. After serving as a helicopter gunner in Vietnam, James Oliver Rigney Jr., who would later write under the pen name Robert Jordan, took up studying physics at the Citadel, the military college of South Carolina. Rigney was particularly fascinated by the study of quantum optics, which applies quantum mechanics to study the interaction between photons and matter, which includes manipulating matter with invisible streams of light while accounting for random fluctuations. If you're a Wheel of Time fan, that already sounds very familiar. Rigney later reported that he had a passing interest in pursuing a doctorate in physics, but ultimately declined and went to work instead. I'll try not to take that personally, Jim. After starting the Wheel of Time, Robert Jordan would often discuss his background in physics in interviews. One of his favorite illustrations to bring up was Schrodinger's cat. He once said, "Schrodinger's cat is really a test in a way. If you can wrap your mind around Schrodinger's cat and accept that, then you are ready to take on quantum physics. I also think if you can wrap your mind around Schrodinger's cat and accept that, then you are ready to write fantasy." So let's recap Schrodinger's cat. In the 1930s, when quantum mechanics was being formulated and unpacked, the predominant interpretation of quantum mechanics described unobserved particles as existing in a superposition of all possible quantum states. This means that an unobserved electron exists with varying probabilities at all possible locations, unobserved light passes through two gates when it reaches a barrier, and that a radioactive element is both undecayed and decayed at the same time. Although this interpretation is supported by experiments and is still widely held today, in the 1930s, Erwin Schrödinger wanted to illustrate how ridiculous this interpretation sounded. Schrödinger concocted a hypothetical scenario in which a radioactive sample is connected to a detector. The detector is designed such that if it receives a signal that an atom within the sample has decayed, it releases a mechanism to break open a flask of toxic acid. This strange device is placed inside a sealed box along with a cat, who dies if the atom decays and the acid is released. Schrödinger argued that since the atom exists in a superimposed state of being decayed and undecayed at the same time, the acid exists in a state of being released and trapped, and so the cat is in a state of being dead and alive. Now, some people will think that this means that it's a coin toss as to whether the cat is alive or dead, but as Robert Jordan summarized, no, the cat is not either way, it is both. It is 100% alive and 100% dead, and both things are true, and must be acceptable as true. If you cannot accept this as true, then you are not ready for quantum, for the most basic quantum physics, much less getting into anything beyond. Jordan saw quantum mechanics as an intellectual gateway to fantasy, where if you can imagine a cat being alive and dead at the same time, then you can imagine new worlds for fantasy writing as opposed to rehashing what's already been done. He said, "I browse mythology, but I think if you've studied it too closely, there is a tendency to be too grounded in it, an unwillingness to start twisting things and bending things too far. In physics, you expect it to twist and bend, and you say, how does that work? What can I come up with? I wonder how far this thing will bend." And if there's one thing that the Wheel of Time series does, it tests the limits of how far the world can bend. One other interesting note about Jordan's physics background is that even though he pursued a career as a fantasy author, he still got invited to talk about physics. Here's how he described his approach in those situations. "As a matter of fact, the thing that I find very interesting is that I don't really follow theoretical physics to any degree now. I sometimes get stuck on panels with theoretical physicists. I'm always afraid that I'm going to be left way behind because I haven't kept up in the area, but I find that I can keep up quite nicely, as long as, while they're discussing theoretical physics, I discuss theology, and I find myself able to keep up quite nicely talking about the same thing." So in this series, we're going to take a look at some of the specific ways in which physics shows up in the Wheel of Time. If you're not familiar with the Wheel of Time, do yourself a favor and start reading these books. You've got a little bit of time before the TV series comes out. The Wheel of Time is coming to Amazon Prime, and I could not be more excited to see this story on television for the first time ever. Yes, I know what I said.